And that's how you combine like terms. If they're not like, you leave them alone. So here, 2x plus 4x plus 8x. First of all, how many terms? 3. Are they like or not like each other? Do they have the same variable to the same power? X, x, x. Yes. The numbers don't matter. I've got 3 like terms. That means they can be combined. So my answer is going to be the sum of the coefficients. 2 plus 4 plus 8. 2 plus 4 is 6 plus 8 is 14, right? No. 2 plus, 14, yeah. So I've got 14 of these things called x. And that's the answer. You keep the variable the same and you add the numbers in front, or combine the numbers in front to get the answer. 2 plus 4 is 6x, plus 8x is 14x, and that's the answer. All right? It works the same way with subtraction. If I have 2x and take away an x, if I have 2 apples and take away an apple, what do I got? I got 1 apple, right? So 2x minus x just equals x. I don't have to say 1x, right? Even though the 1 is there, we don't write it. So 2 of them, take away 1 of them, leaves 1. I mean, translate this if it's hard to do letters, translate it into apples and bananas and you get the right answer. 2 apples, take away an apple. Oh, I got 1 apple. There it is, right there. All right, 3xy minus 3xy. Are they like terms? Yeah. I have 3 of them and I take 3 of them away. 3 minus 3, I got 0 of them. 0 is the coefficient. 0 is being multiplied times xy. And 0 times anything is just 0. We don't even have to say 0xy because it doesn't matter what xy is. If I multiply them by 0, the answer is going to be 0. So if I have the same thing, even if it's an algebra chunk, and take away the same algebra chunk from it, you get 0. Does that make sense? I hope so. All right. Your assignment involves, well, what the book says is to collect like terms. I hate that. We don't collect things like butterflies and things like that, all right? What we really want to do is combine, is a much better way of thinking. Combine like terms, all right? Because combine takes into account negative and positive. I add some negatives together, I get more negatives. If I combine some positives together, I get more positives, all right? So we have this expression here, all right? And the idea is to combine like terms, all right? So the first thing I have to do is figure out which terms are like each other. I want to identify like terms. In other words, which of these is the same variables to the same power. And I don't care about plus minus signs, I don't care about numbers. And that tells me that 3x here and plus x are like terms. And now I've got plus y and I've got minus y, are both the same variable, all right? So now that I've identified the like terms, I can combine the like terms. I can take 3x plus x. 3 apples plus another apple makes 4 apples, or 3x plus x just makes 4x. All right? Variable doesn't change when you combine. When you add or subtract x's, stay x's in the answer. And now I've got this plus y, take away a y. I've got an apple and I remove an apple. What do I have left? No apples. Or no y's. The y's are gone. xy, or this y, wipes out that y and it just disappears. And so after combining all this thing, you get something simple like 4x. That's the answer. All right? So understand that when terms cancel each other out, they in effect go away. They become 0. Okay? All right, so to combine like terms, all right, here's the steps you need to do. Make sure you have this in your notes. Make sure you refer to this as you're doing your homework, all right? Number 1, you have to identify the terms that are like. You can do that by underlining, circling, draw a triangle, make a square around the terms that are the same. All the triangle ones are the same, all the circle ones are the same, and so forth. Then you identify which terms are like the other terms. Then you combine the numerical coefficients of the like terms. All right? Now you forget about the variables and just combine the numbers. And then keep those variables exactly the same, only the coefficient changes. So you'll see things like some big, long, hairy expression like this. All right? So first we want to identify like terms. Here's 3x. Anything else like 3x? 2x squared? Nah, that's a different exponent. 4? No, there's no x there. X squared? Nah. Minus x. Ah, there's a like term. So 3x minus x. You would say combining 3x, take away an x, and the answer is, yeah, 2x. 3 apples, take away an apple, leaves you 2 apples, 2x. All right. What about this? Anything like 2x squared? Well, I got another x squared there, so I got plus 2x, and I always keep the plus or minus sign with it. And here's another plus x squared. So those two are like terms that can be combined. 2 of these plus, there's a 1 there, remember? So the coefficient, right, even though we don't write it, says plus 1. So adding the coefficients together, 2 plus 1 gives me plus 3 of these things called x squared. All right? And please, you must separate these two terms. They are different terms, and here's where the plus 3 comes in, and you have to write the plus sign. Because if you write 2x, 3x squared, you've written one term multiplication. This is all a multiplication problem. These are two terms, totally different, all right? Please make sure that this plus sign gets used to separate the two terms, all right? And then I've got a plus 4 and a minus 1. I can combine 4 minus 1 and get a plus 3. And again, you have to have plus 3 here to separate the terms. And so this whole mess on top becomes much simpler with this on the bottom after we combine like terms. All right, let's give that a try in lesson 84. Again, you might want to go over some of this again, rewind this, go back, understand combining like terms deals with only the numerical coefficients, putting them together, leaving the variable the same. So lesson 84, give it some practice, A to I and 8 to 11.